Hello dear students, welcome to my physics channel physicsrnt. Today we are going to solve some multiple choice questions based on electromagnetic induction. At first, let us review the related formulas and helping tips. Magnetic flux linked with a closed coil having n turns each of area A is given by phi is equal to n AB cos theta, where theta is the angle between the normal and magnetic field. So, it can also be written as n into A vector dot B vector. According to Faraday's laws of electromagnetic induction, induced EMF in a closed coil is directly proportional to the rate of change of magnetic flux. So, it gives E is equal to minus d phi upon dt, where d phi upon dt is the rate of change of magnetic flux. Minus sign comes due to Lenz's law. So, it can be written as minus E is equal to d phi upon dt, and minus E may be denoted by back EMF, which gives the direction of induced EMF. Next, electric charge flowing in a resistor due to magnetic flux change is given by Q is equal to delta phi upon R, where delta phi is the change of magnetic flux and R is the resistance of coil. Self-inductance of a coil is related with current and magnetic flux by this relation: phi is equal to L into I. Energy stored in a coil is equal to half L into I square, where I is the current flowing through the coil. Motional EMF E is equal to BLV, where L is the length of conductor moving with velocity V in perpendicular magnetic field B. Induced EMF in a circular disc rotating in perpendicular magnetic field is given by E is equal to AB into F, where B is the magnetic field perpendicular to the area A of the disc rotating with frequency F. Faraday's and Lenz's laws are based on energy conservation law. Now question number 1, the question is, Lenz's law is the consequence of the law of conservation of. These are the options. As we know, Lenz's law and Faraday's law of electromagnetic induction are based on the law of conservation of energy. Therefore, the correct option will be D. Next question number 2. The question is, if a coil of 40 turns each of area 2 cm square is suddenly removed from a magnetic field, a charge of 2 into 10 to minus 4 coulomb flows into the coil. If the resistance of the coil is 80 ohm, the magnetic flux density in Weber per meter square is. These are the options. So, solution to question 2. As we know, charge flowing due to magnetic flux change is Q is equal to delta phi upon R. Here delta phi is NA B1 minus B2 upon R, which is NA B1 upon R, because B2 is 0. Therefore, B1 will be equal to R into Q upon NA. R is 80 ohm, Q is 2 into 10 to minus 4, N is number of turns 40, and A is area of each turn 4 into 10 to minus 4. So, it is 1 Tesla or 1 Weber per meter square. So, the correct option will be C. Next question number 3. The question is, a coil having an area 2 meter square is placed in a magnetic field which changes from 1 Weber per meter square to 4 Weber per meter square in 2 seconds. The induced EMF in the coil is. Now solution to question 3. Back EMF EB is equal to d phi upon dt, which is d upon dt into AB. A is constant and B is changing, so it is A into B2 minus B1 upon time. A is 2, B2 is 4, B1 is 1 and time is 2. So it is 3 volt and correct option will be D. Next question number 4. The question is, a coil of resistance 400 ohm is placed in a magnetic field. If the magnetic flux in Weber changes with time t in seconds, as phi is equal to 50 t square plus 4, then the current in the coil at t is equal to 2 seconds is. Now solution to question 4. We know back EMF EB is equal to d phi upon dt. So it will be d upon dt. Phi is 50 t square plus 4, which gives 50 into 2 into t plus 0, which is 100t. Therefore, at t is equal to 2 seconds, current will be equal to EB upon R, which is 100 into 2 seconds upon R is 400. So it is 0.5 ampere and the correct option is B. Next question number 5. The question is, a current of 2.5 ampere flows through a coil of inductance 5 Henry. The magnetic flux linked with the coil is. These are the options. Now solution to question 5. We know magnetic flux phi is related with self-inductance of coil and current as phi is equal to L into I. So here L is 5 Henry and I is 2.5 ampere. So it gives 12.5 Weber. So the correct option is C. Next question number 6. The question is, in a circuit with coil of 2 ohm, coil of resistance 2 ohm, the magnetic flux changes from 2 Weber to 10 Weber in 0.2 second. The charge that flows through the coil during this time is. Now solution to question 6. We know charge flowing through a coil due to flux change is delta phi upon R. Here delta phi is 10 Weber minus 2 Weber, 10 minus 2 Weber upon resistance is 2 ohms, 2 ohms. Therefore, this will be 4 Coulomb. Charge will be 4 Coulomb, that is C is correct answer. Next question number 7. The question is, a wire of length 50 cm moves with velocity 300 meter per minute perpendicular to a magnetic field. If the EMF induced in the wire is 2 volt, then the magnitude of magnetic field in Tesla is. These are the options. Solution to question 7. Here we know motional EMF induced in a conductor rod moving in perpendicular magnetic field is given by E is equal to B L V. Therefore, B will be equal to E upon L into V. E is given to be 2 volt upon L is 0.5 meter and V is 300 meter upon 60 seconds. So it is A is 2 volt, L is 0.5 meter and V is 300 meter per minute, means 300 upon 60 meter per second. So it is 2 upon 0.5 into 5, which is 0.4 upon 5 means 4 upon 5 means 0.8 Tesla. So the correct option is C, 0.8 Tesla. Next question number 8. The question is, a coil of area 100 cm square with 500 turns is placed in perpendicular magnetic field of 0.1 Tesla. The field is reduced to 0 in 0.1 second. The induced EMF in the coil is, these are the options. Now solution to question 8. Induced EMF will have magnitude E is equal to d phi upon dt, which is d upon dt n a b. Here n is 500 and a is 100 cm square, which are constant. So it may be written as n a dB upon dt, which is n is 500 turns, a is 100 cm square means 100 into 10 to minus 4 meter square. dB upon dt is, initial field is 0.1 Tesla and final field is 0. So it is 0.1 minus 0 in time 0.1 second. So 0.1 cancels out and it gives 5 volts. So the correct option is A, 5 volt. Next question number 9. The question is, a rectangular coil of 20 turns of cross section area 20 cm square has a resistance 100 ohms. If the magnetic field which is perpendicular to the plane of coil changes at the rate of 100 Tesla per second, then the current in the coil will be. Now solution to question 9. Here back EMF E is equal to d phi upon dt, which is d upon dt, phi is n a b. So it is d upon dt n a b. N and a are constant, so this becomes n a dB by dt. Again E can be written as I into R from Ohm's law, therefore it will be equal to N A dB by dt, which gives current I as N A dB by dt upon R. Putting the corresponding values, we get N is 20, A is 20 cm square means 20 into 10 to minus 4 and dV by dt is 100 upon resistance is 100, which gives 0.5 ampere. So the correct option is C. Next question number 10. The question is, a coil having 500 square loops, each of side 10 cm, is placed in normal magnetic flux which increases at the rate of 1 Tesla per second. The induced EMF in volts is, these are the options. So solution to question 10. The induced EMF E will be equal to d phi upon dt, which may be written as d upon dt. Phi is NAB. Here N and A are constant, therefore it becomes NA into dB by dt. Putting the corresponding values, we get N is 500 turns, A is 0.1 into 0.1 and dV by dt is 1 Tesla per second. So it gives E as 5 volts. So the correct option will be B.